Alright, let us get started. We shall cover wiring of a power supply. We won't actually wire this guy up because it is dead. The smoke rolled out of it. Good thing I was actually in the shop too, because it like rolled out of it. It literally had flames in the inside of the on the inside of the box. So who knows how bad it could have got if I wasn't here. And nothing was actually happening either. It was just sitting plugged in. Way less than its loaded rate too. So first things first. You'll have a neutral, line, and a ground. On your outlet, you'll also have 3 holes, 2 slots, and 1 roundish hole. Those are your neutral, your line, and your ground. We're dealing with 120 volts AC. It's enough to put you on your butt or possibly kill you. So all care should be taken. Now, the way AC works is the line carries 120 volts. The neutral is neutral, has no electricity through it. You could, in all honesty, not safely, but in all honesty, you could take the neutral and stick it on your tongue and be alright. The line carries the full voltage, and that's the dangerous one. So to test which one is the line, and I guess the reason I say test which one is the line, because just because you think everything is wired properly into code, that doesn't mean that it actually was. And some electronic devices are picky about what's line and what's neutral. So I'm going to take my digital multimeter and I'm going to put it on V squiggly line 200. I'm going to go ahead and take my ground and put it in my ground, and I'm hoping that my stuff is actually wired right in this place and that it is grounded. And I'm going to probe for my line. And again, one second. So we want to probe for our live line, and as you see in the multimeter, we now have 122 volts. So that's the way that goes. So this is our line. That's our neutral. And as you can see, this is a polarized plug, so I can't plug this plug in that way. I have to plug it in that way. That means that this fat guy is a neutral, the skinny guy is the line. So now I'm going to put my tester on continuity, and I'm going to test for my line. Now if you're using a different, and which you should be, if you're using like a PC style cord. And do I have a line break here somewhere? Because I'm not getting continuity. Must have a bad cord. That figures. That figures. Interesting. Alright, well, yeah, great. Nice show. So anyway, let's assume that we have continuity across the skinny guy and the short guy, which I don't, because the cord is bad, and that's why it's actually cut. But I was hoping it would actually work just for demonstration purposes. Obviously I was wrong. So anyway, so short guy is our line. Alright, to wire this up properly, we leave everything unplugged, and we would take the short guy, actually better yet, we take the neutral, and we put it on the neutral. And the best cord, really, a good cord to use for this is a PC ATX style power cable. So we'd actually take our neutral, which in this case is a long one, screw it underneath that terminal, and we'd take the normally closed, which is NC. On this particular switch it's NC in purple, and our line would go on one side. From the other side, we would take another piece of wire, depending on how long we actually needed it, and we'd then run it to our line. So it would be like a small chain. So it'd go from line, which is the short guy, into the switch, from the switch to line. That way when we actually hit that e-stop switch, it kills the power to the power supply. Now when wiring more than one of these power supplies, you would actually have to take a jumper wire and run it from line on one power supply to the line on the other power supply. Again, please be very careful. This is 120 volts. You'll either fry something or burn something up or something that's not good. If there's any questions or comments, make sure you go ahead and leave them below, or email or something to that effect. Thank you.